Okay. Were you able to go through, I mean, do at least try at least a few? Please respond.
Yes, madam.
Okay. What I wanted to tell you is this. Even if you can't remember anything, go back to your go back and read your books. Then make a note of it that these things I can't remember. But whatever that you can remember, okay, you don't have to go through those things again. So that will be a good thing, indication that those things that you cannot remember, you should work on those things much more, right, before the exam. Okay, let's start the discussion. Okay, question number 1. Okay. Now, okay, there's a water sample, equimolar. And question number 1, is selective precipitation of XOH and YOH possible? Justify your answer. Can someone answer? What is your answer? Please join. Okay, it doesn't matter. You don't have to, I mean, be perfectly correct. We are learning. This is a learning session. Okay. Were you able to do it? Work on this? We discussed. Selective precipitation of XOH and YOH possible? What is the answer? Can someone tell? No answer. Can y'all hear me? ඔගලට ඇහෙනවද මං කියන දේ?
Yes, madam.
Yes, ma'am.
Okay. I have given you hints also.
Madam,
Yes, tell please.
if the KSP value of this ratio of the KSP value to precipitate is greater than 10 to the power 4, then we can achieve selectivity because they said contain equimolar X plus and Y plus ions.
Okay, that's correct. That is the justification. So what is it possible in this case?
No, madam.
It's not possible because it has to be the KSP higher one over KSP lower one. So higher one is -6, 10 to the power -6. Lower one is 10 to the power -8. So you will be getting something with 10 to the power -2. Okay. If you just show that the ratio, how the ratio is taken, and it is less than 10 to the power 4, then that is the justification. And answer is no. Let's look at the answer. This is just the answer. Okay, even if you say no, okay, you don't have to write selective precipitation, this and that. Okay, right. Let's move to the next one. Are you with me, students?
Yes, madam. Yes, madam.
Red colored, some line was drawn. I don't know how it. Okay. Right. The precipitation started when the solution pH was 9. Calculate the concentration of the metal ion which starts precipitation first. Okay. Selective precipitation is not possible. So this is, I have drawn, I ask you to draw clear pictures of whatever that you are, when you are reading the question, to draw. So you have a solution of pH 9 at that time. Precipitate just started forming. And precipitate was formed by adding sodium hydroxide. Okay. What is the first precipitate that will be forming, although selective precipitation is not possible? මොකද්ද මුලින් precipitate වෙන්නේ?
XOH.
XOH. So I'm not asking what is here. It's not directly being asked, but you have to, when you are writing, you have to write. Okay. It is XOH. Right? Look at the thing. Okay. I'm not asking why it is XOH. XOH. You don't have to write that. You have to just write it is XOH which precipitate first. Because I'm not asking you the reason. Then the precipitation started when the solution pH was 9. So now starting is it's in equilibrium. So I told you to, because solid and liquid, then the equilibrium constant is Kp, just at the saturation level. So you have to write down the equation for solubility product, Kp, for XOH. Were you able to write? Liwada? Katya liwada? No answer.
Yes, madam.
Okay, it's very easy. XOH Kp equals X concentration into OH minus concentration. Okay, so Kp value you know. So, sorry, it's not the X value that you know. You have to find out the X value, but OH minus concentration, you can get it from the pH value. pH is 9, then pOH is 5. How? Because pH plus pOH is 14. If pOH is 5, OH concentration is, P stands for minus log, you get 10 to the power minus 5. Okay? So when you substitute, you will be getting this value. Did you get it?
Yes, madam.
Okay, very good. Very easy question, but you have to put a little bit of thinking because only the pH information given, how to find OH minus, what is being precipitated first. Those are the things you have to think, right? Okay. Let's look at the third question. After completion of precipitation, the precipitate was filtered, washed with cold distilled water, and dried at 110 degrees of centigrade. Give 3 possible reasons for selecting cold distilled water as washing solvent. Can one by one tell what are the reasons? Can one person tell one reason? Washing solvent?
To remove impurities on the surface of precipitation.
Very good. Don't write just to remove impurities. You have to write to remove impurities on the surface. Okay? By washing, only those will go out, will be removed. Okay. One answer is correct. Another one? Another answer? Majority is silent. Tell the answer, even if it is not correct, it doesn't matter. Look at the book and give me the answer. Then at least you will know that I have not studied. What is the answer? Give me one more reason.
It's not reacting with the precipitate.
Very good. It's not reacting with the precipitate. Another one. Not only reacting, another one.
Madam, we can reduce the solubility loss, madam, because it's as a small solubility, right? So when it's cold, it will have a less KSP. So we can reduce the solubility loss if we are using cold water.
You can reduce the solubility loss. The solubility loss is that you are assuming, okay, it's not direct. Your answer is not direct. If you put it in direct way, it should not dissolve the precipitate.
Yeah, madam.
Okay.
It will like have less solubility.
Yeah. It should not dissolve the precipitate. It is having less solubility with what? With this reagent. Okay. Anything more? Okay. Sometimes there will be more, right? Okay, right. Then let's move on to look at the, yeah, I hope the answer is there. Refer the book, right? Okay. Then next one. Another person suggested that it is better if you had heated the precipitate. Okay. And to get the precipitate in pure form, do you agree? Give reasons for your answer. I think we more or less discussed this, no? In the morning. So one gave me the answer, yes, it's good to increase the temperature or heat. Why? Do you agree? Yes. Give reasons. That is to digest. By digestion, what are you going to achieve? You are going to get rid of occluded impurities. And then you are going to make the smaller particles, nuclei, soluble and get bigger particles. Okay, so then you're filtering, and also filtering will be easy, drying will be easy, washing will be easy, all that will be easy, right? Okay, these are the answers. Smaller particles redissolve and you get large particles. Large particles are easy to wash and dry. And contamination is also less. Then occluded particles, occluded ions can also be removed. Do you see? It should be a complete answer. Right? The reason you should tell to get these and why should I get like this? Then, to get larger particles, why? Because it's having these advantages. Like that, you have to write the answers. Okay? Right. This also, I think we have discussed. Right. Then let's move to the next one. The weight of the precipitate obtained. Okay. Were you able to calculate? This is a situation now. How many of you were able to calculate? Calculate කරන්න පුළුවන් වුණාද?
Madam, I got the answer,
It's
but
okay.
I don't know whether it is correct or wrong.
Yeah, usually my way of marking is I give just 1 or 2 marks for the final answer. I am most of the time studying your method of doing, right? Okay. So now look at this. You have a challenge. The total precipitate, first you have to identify it's of XOH and YOH, right? And it's very simple, but you have to, think clearly without making it complicated. And you know the way. Now think if it had been just one uh, one compound only, how do you calculate? Think that it's only XOH. කොහොමද weight එකක් calculate කරන්නේ? How now it is calculate the percentage of X. Weight is given. Weight of X. හිතන්න බලන්න. You have only XOH. Then how? Just tell me. Then you will not get wrong.
First, we have to calculate number of moles in precipitate.
Number of moles in the precipitate. How do you calculate the number of moles?
Weight divided by molar mass of the
Very
if
good.
it is
Weight
XOH.
divided by molar mass. Then you get the number of moles of the compound. Got it? Okay? Harida, you
Yes, ma'am.
get the number of moles of the compound. Then, what is it been asking? Number of moles of one element. Then you have to know in 1 mole of the compound, how many moles of the element is there? For an example, in 1 mole of XOH, how many moles of X is there? It's 1. It's just XOH. Okay? So you get number of moles of X. Harida?
Okay,
Am I
madam.
correct? Okay. Then how do you get the weight? You know the number of moles. Then
Multiply by molar mass of the X.
multiplied by the atomic weight of X. Okay, good. Same way you apply for the mixture. Okay. Now, this is equimolar. That is number of moles of XOH is equal to number of moles of YOH. Let the number of moles be N. Okay. Let the number of moles be N. Same number, no? Right. If the number of moles is N, what is the weight of XOH? Can you find the molecular weight of XOH? Pulwanda?
Yes, madam.
Yes. Right? So, N into, now, this XOH and YOH, now you have the total weight. That is the weight of XOH and YOH. Am I correct, Harida?
Yes,
This
madam.
one, yeah, 1.24 is weight of XOH plus weight of YOH. To find the weight of XOH, you have to know the number of moles, right? Then if you know the number of moles, then you have to multiply with the molecular weight. Harida? So what is the weight in terms of number of moles and the molecular weight? If the number of moles is N into molecular weight of XOH. Okay, then YOH, same number of moles. N into molecular weight of YOH. So you get an equation. And the addition of these two is going to be equal to 1.24. Am I clear? Were you able to get up to that? ඒක ගයන්න පුළුවන් වුණාද?
Yes, madam.
Okay, very good. Only N is the thing that you do not know. Then find N. See, molecular weight of XOH 70, molecular weight of YOH 80, then number of moles, if it is N, then you get 70 into N plus 80 into N, that is 150. N is equal to this. Then you can get the value of N. Then weight of X, in 1 mole of XOH, you get 1 mole of X. Then in this number of moles, you get this number of X, same number of X. Then into atomic weight will give you the weight of X. Then the percentage. Weight divided by the total weight of the precipitate into 100. Were you able to get this value?
Yes, madam.
Very good. I'm so glad. How about the others? කතා කරන්නේ නැත.
Yes, madam.
Okay, very good. Now think that it's given in a very tricky way. Right? Very simple one. Right? But that is the thing. That is where you have to, your thinking is needed there. Right? Very good. Right. Okay. Then let's move on to this one. Right. A solution of acid. Now I am moving on to, okay, first I want to tell you, right. Shall we summarize what is important in gravimetry? Okay. Now you have gone through the book one, the initial sessions and the gravimetry. Okay. Initial sessions are about the error, whatever the method that you are going to do, the errors, how to overcome them, then the precision, how to improve the precision, and also definitions or the meanings of different parameters that is used in analytical chemistry. What are those? Sensitivity, selectivity, minimum detection limit, interference, matrix, linearity, there are some more. I can't remember. Anyway, you have to know. You have to get the meaning because we are going to apply. Definition is also needed. Meaning is also needed. Right? So, okay. After that, you get the first method, gravimetry. Number 1, you have to write down all the steps. Like any method, how to get a good error-free best precipitate. Okay, you start with sampling. You have to get an idea about the sampling method. Right. Then the requirements. Can all the precipitates be used for gravimetry? No. What are the requirements? Okay. With that, you take a sample. Then why are you carrying out each and every step in such a way? You can make a nice table and write the steps and the reason. Okay. So you end up with that. Then you think about the aspects of gravimetry or the properties of gravimetry as a method. Selectivity, how to achieve equimolar, non-equimolar. Okay, then sensitivity. What is the bottleneck when you are talking about the sensitivity? The balance. Okay, interference, possible errors. Then how to overcome these things? How can you make a small weight of an analyte into a bigger weight, making a precipitate having a large weight, like nickel dimethyl So even a small amount will end up with a large weight. Okay? Got it? Then what are the advantages of this method? And what are the disadvantages of this method? Okay, that's all. Calculation is very simple in gravimetry because all the time, if it is weight, if you know the formula, it will be number of moles into molecular weight or number of moles into atomic weight. Okay, so if you know these things, then you can answer any question, right? But the thing is you have to be very careful when you are right now. Think that, say that maybe some, say the tricky things, if you sometimes, if you add more precipitating agent, it will make another complex which is soluble. Those are the deviations from the normal way. So you should not add the things in excess. Then say common ion effect. Even a smaller, to get the precipitate with a low concentration, what are the things that you can do? Those points, small things, you can write like the improvement, how to make the method improve. Under those things, you can just have a small note. Then you will remember. Okay, right. Let's move on to the now. Buffers are there. I will be touching that in the next question. So we are going moving on to the unit 2, session 1, acid-base titration. Okay, sorry. Okay. So I told you to draw a diagram, schematic diagram. You have H2D and HCl. Okay, were you able to draw this? And the Katya? නැත්නම් මං ඇඳපු එක දිහා බලන් ඉන්නවද?
and the madam.
Okay, good. Right? හැම වෙලේම එහෙම පුරුදු වෙන්න. That is good. Okay, so before starting the titration, what do you have? You have fully dissociated HCl, H plus Cl minus, then H2D. If a Ka value is given, definitely you will know Ka value is given because of the partial dissociation. But depending on the value of the Ka, right, you can decide whether it is acting almost like a strong acid or a weak acid. Here, K1 like a strong acid first dissociation, and K2 is small like a weak acid. So when you have H2D and HCl, the first dissociation is taking place in the aqueous solution of H2D like HCl. So first dissociation, you get H plus and HD minus. So look at the first flask before starting. You have H plus given by 2 dissociation equations. HCl and H2D first dissociation. Then you have total H plus, Cl minus and HD minus. Okay. Now, since the situation is such, you have a lot of H plus and the second dissociation also, dissociation constant is also poor. So it's not encouraging for the second dissociation. It is not going to happen at this situation, not at the very beginning. So the dissociation of the weak acid stops at HD minus. Okay. You have to get an idea, otherwise you can't draw the titration curve. Okay, then what is happening? You are adding sodium hydroxide. What is going to be H plus contributed by what? Will be titrated first. Can anybody answer? Please answer. Total H plus is contributed by HCl and H2D. But what will be titrated first?
H plus contributed by HCl, madam.
Yes, because it's very, very strong. H plus contributed by HCl. Then there is another one, no? H2D also contributes. So before the H plus of HCl finishes, H plus given by H2D also going to be titrated. Although it's H plus of HCl, which will be starting the reaction first. H plus of H2D is not going to wait until that H plus is over. So it's like that they are being tried reacting together. Okay? So what is happening now? What is the initial pH? What are the changing parameters for the titration? You know, there are 2 changing parameters. I told you, one is all the time the volume added from the burette, sodium hydroxide. Then the changes happening in the flask. The change that is continuously happening in the flask. So if it is acid base, It's either H plus or OH minus, which is going to be changed throughout. So actually it's pH. Now here, at the beginning, you have a lot of H plus. Is the pH low or high?
Low value.
Low. Okay, right. So all these things that I'm talking about, you have to write down because there's a part telling to justify. You have to tell HCl is a strong acid, fully dissociated. H2D, first dissociation is taking place like a strong acid, but not the second, at the very beginning. So when you start titrating, so H pluses contributed by both will be reacting one after the other, like just one H plus lot. Okay, then what happens? This H plus, what is the reaction? Sodium hydroxide plus H plus. So either you can write the formation of water or the full reaction. NOH plus HCl, NaCl plus water. Then NOH plus H2D giving you what? H plus plus NaHD. Okay? NaHD. Right? Okay. Then okay. Then right. Then either you can write like that or you can write the water formation equation also. But it's better all the time to write the reaction with sodium hydroxide and HCl and sodium hydroxide and H2D for this. Okay? Right. So when this H plus is over, what is happening? Now H plus is going to be decrease, decrease, decrease. Then pH are going to be increase, increase, increase. Then what? Then after that, what will happen? When this H plus is over, then there will be a drastic change in pH. pH will be rising. First end point. Then what is happening? Can anybody tell? From that point onwards, can anybody explain? Can anyone explain? Try, you reach the first end point. H plus is less. What will happen? It will encourage the dissociation of HD minus. Then H plus released by the HD minus will be starting to react with sodium hydroxide. Write that equation, it's given there with K2. Okay. Then after that H plus is over, then what will happen? When the reaction is taking place with this H plus and sodium hydroxide, again gradually pH will be increasing, increasing, increasing. because H plus is going to be lower and lower and lower. Then finally, there will be no H plus in the flask and no HD minus. Then that means you are reaching the second endpoint. Okay, you are reaching the second endpoint. Okay, after the second endpoint. Okay, so you have two endpoints now in the curve. After the second endpoint, you are going to add sodium hydroxide, but no H plus. You are adding OH minus, then pH will be rising slowly. Okay, so in the explanation, you have to write down what is there at the beginning. Justify. Why are you telling those things are there, but not all? Then what will happen during, at the very beginning, when you start the titration? Then what is happening at the end point? Then after the end point? Then after the end point, the situation. If there is a reaction, that again. Then the second end point. Then after the second end point, what is there? Okay, so if you have a very clear picture, it's easy. That's why I'm all the time encouraging you to draw. Right. Let's look at this. Were you able to think like this? Students, please respond. Were you able to draw this?
Yes, madam.
Very good. Very good. Two-step curve, right? Starting with low pH, right?
Excuse me, madam.
Yes.
Now it's okay, madam.
Why?
මේ කලින් ස්ලයිඩ් එක පෙවුනේ මැඩම් මා ඒකයි බැලුවේ. හරි දැන් හරි මැඩම්.
පෙවුන්නේ නැද්ද කලින් ස්ලයිඩ් එක?
මේ ප්‍රශ්නේ තිබ්බ ස්ලයිඩ් එක තමයි පෙවුනේ. මේ මැඩම් මං අර ග්‍රාෆ් එක අඳින්න පුළුවන් වුණාද කියන නිසා මං හිතේ මැඩම් ග්‍රාෆ් එක තිබ්බ ස්ලයිඩ් එකක් මේ දැම්ම කියලා ඒක පෙවුනේ නැහැ. ඒකයි ඇහුවේ.
නෑ ඒක නෙවෙයි.
ඕකේ මැඩම්.
ඒක මම පස්සේ පෙන්නන්නම්. හරිද?
හරි මැඩම්. හරි මැඩම්.
එතකොට low pH, H3L strong acid, fully dissociation, H2 monkey before titration, all these things you have to write. Harida, then of this point is very, very needed. The selectivity of H2D, whether now HCl is strong, now whether the dissociation of this diprotic acid having two H pluses, whether they are going to release their H pluses in stepwise manner. It's important. Okay, so that also you have the equation, the limitation is 10 to the power 4. It's large. So then that means after releasing the first one, only the second one is going to be released. Okay. So all that you have to write very slowly. I have written only a part of it, right? So now here you justify the initial part only, right? But the curve, okay, what is there at the beginning? Low pH, then okay, what is going to be titrated? Endpoint 1, HCl and first H plus of the weak acid. Then when it is over, you get a rise in pH. Okay, so that is the endpoint 1. Then the second dissociation is taking place. Then gradual increase. Then once that is over, second endpoint, then with the sodium hydroxide addition. Okay, and there's another point. So the axes, very important. If the axes are wrong, I'm not going to give marks. This gives, all your explanation will be wrong if the axes are wrong. Right? If the axes are wrong, all your explanation is going to be wrong. Right? So then there's an important point here. That is half endpoint. Okay. When you write down the dissociation equation, dissociation constant equation, and then you get a relationship. And there is a time at which the salt produced and the acid remaining is the same. It's all the things are given in the book. Right? Then at that point, pH is equal to pKa2. That actually it's by the Henderson-Hasselbalch equation. Henderson-Hasselbalch equation, right? When you derive it, there's a point. At the half end point, those things are going to be equal. So pH is going to be equal to pKa2 here. But pKa1, we can't say where it is because it's mixed with HCl. So look at the points that you are going to get marks. 2 axes, definitely the first thing I will be looking into. Even that, if the axes are correct, you will be getting some marks. Then beginning, low pH or high pH. Then shape, 1 step, 2 step. Then the labeling, right? Endpoints. If there is one endpoint, just endpoint is okay. But then even if there is one endpoint, half endpoint is in. Then if there is 2 endpoints, okay, you have to say endpoint 1 is when and endpoint 2 is when. Okay, right. That is a complete picture of this picture of the titration curve. Right. Then, okay. Any questions on that? Harida, are you okay?
Yes, madam. Yes, madam. Clear, madam.
Okay. Yes. Do you have any questions? Someone talk, but okay, I'll move on. Okay. Sorry. If the first endpoint and the second endpoint obtained by 25 and 40, calculate the concentration of HCl in the initial sample. Were you able to calculate?
Yes, madam.
Okay. Now, first endpoint is what? 25. That is for H plus given by HCl plus the first dissociation. And 40 is for all. H plus by HCl, H plus by the first dissociation and the second dissociation. So the difference is going to give you what? Can you answer? Difference of the two is going to give you H plus required for what?
Second dissociation.
Very good. Sodium hydroxide required for the second dissociation. H plus resulted by the second dissociation. Okay. So you know the, okay, so the difference, that is 15 milliliters were needed to titrate just 1 H plus of the H2D. So the first H plus of H2D will be needing another 15. If the second one needed 15, first one also needed 15. So for the first endpoint was 25. Out of that 25, 15 was taken by H2D. So only 10 is taken by HCl. Now simple. You know the concentrations. It's just HCl and sodium hydroxide reaction. Were you able to do that?
Yes, madam.
Very good. Others are not talking. I don't know why. Look at this. First endpoint 25, second endpoint 40. So 40. So first, now difference of this much at that point, second H plus was titrated and 50 milliliters was taken. If the second H plus needs 15, first H plus also needs 15, but 25 was consumed. So the difference should be for HCl. Right. So the calculation is very easy. So it's 10 ml needed. So sodium hydroxide 10 ml. What is the number of moles? Stoichiometry is 1:1. Same number of moles of HCl is there in 25. So the concentration. Remember, don't write anything just directly. Write all the steps. You will be get at least scoring some marks, right? Okay. Right. During the titration, okay, then during the titration, what was the buffer form after the first endpoint? Predict the burette reading, giving reasons when this buffer has shown the highest capacity. What is a buffer? Tell me what is a buffer? What is a buffer? How do you make a buffer? Can you answer?
It consists weak acid or base and its salt.
Weak acid or base and its salt. So do you have that?
Yes, madam.
After the first endpoint, right? You have a weak acid. What is a weak acid? Is it
HD
H2D
minus.
or HD minus?
HD minus.
HD minus. Very good. What is the salt form?
N2D.
What is the salt form with now? Acid is HD minus, and what is the salt there? With sodium hydroxide, you get
Is it N2D, madam?
Na. We are talking after the first endpoint. Okay, we are not now after the first endpoint. You get HD minus, and H plus release is going to be forming water, and okay, you get the D2 minus, that is Na2D. Correct. Very good. Harida, Hatti Harida. So you have the salt and you have the weak acid. So what was the buffer formed? Buffer is formed by, you have to write HD minus and Na2D. Then predict the burette reading. Now, all the time, whenever they ask for the buffer, you write down the Henderson-Hasselbalch equation. It's easy then. Predict the burette reading, giving reasons where this buffer had shown the highest capacity. Okay, what is the highest capacity? When do we have the highest capacity? To get
When
the high, tell. What is
acid
the
and salt
salt, acid and salt.
concentrations are high.
Acid and salt concentration should be high. Not just the acid, not just the salt. Both should be high. At the beginning, acid concentration was high. At the end, salt concentration was high. Salt is a product. Okay, that is not what we want. We need both to be high at one point. It cannot be as high as at the beginning or at the end, just one. But both have come to a middle point and having somewhat high concentration. That is when the salt concentration and the acid concentration are equal. Am I correct?
Yes, madam.
Okay. Now look at this. Now look at this. It is asking what is a buffer form and predict the burette reading, give reasons. 3 parts are there. Okay. Buffer form, weak acid is this. Buffer form with this. Answer 1. I told you to write this equation because then you are going to predict, give reasons with the capacity. When the two salt and acid concentration are equal and high, then it's going to be same. And cancel it out, it's going to be log 1, which is 0. So at that point, pH is going to be equal to pKa. Okay. So what is the point at which these two are equal? That is half endpoint. At that point, at half endpoint, pH is going to be pKa. What is the half endpoint value? After the first endpoint. First endpoint is 25, second endpoint is 50. So half of the second endpoint is going to be 7.5, 15 plus 7.5, 32.5. Did anybody get this?
Yes, madam.
Very good. I'm happy, very happy that if you can think like that, now you have to understand this is not direct, right? You have to put a lot of thinking into it, right? Very good. Right. Okay. Right. Then comes the EDTA titration. Okay. So were you able to do it or do that? Now what's the time now? Okay. It's we are supposed to, now it's 8:30. Right? We started at 6:30. Now it's 8:30. Shall we do the rest tomorrow? Shall we do the rest tomorrow after Dr. Kumudika?
Okay, madam.
7:30 to 8:30? You can try again. Okay, good. Then I will wind up. Tell your friends also to join with us tomorrow at least, same time. So I'll stop recording